So this is meant to be an overview. So hopefully you if you do have follow-up questions or questions about more complicated scenarios, then later on we are going to make this a formal, like there's going to be something called the multiplication rule for independent and dependent events. And we are going to touch upon that briefly. But please just make sure that you're approaching this sort of at surface level. Independent events are events that don't affect each other. So the first event doesn't have any bearing on the second event, meaning you could calculate the second event without knowing what the first event is. So if you have a bag and there's 2 black marbles and 3 red marbles, you reach into the bag, select a marble, see what color it is, and replace it in the bag. Then you repeat the process. So you just put the marble back every single time. The probability that A is red, we can examine the simple probabilities because they're independent events. That's 3 out of 5. So 3 marbles out of 5 total marbles. And that's the probability that you pull a red marble first. So you put that back. And then you can find the simple probability that B is red, which is 3 out of 5, because you put the marble back in. And then you start to use our new notation here. So it says, what's the probability that B is red given that A is already pulled and it's already red? Okay, so we take a marble out, it's red, we mark it down, it was red, event A is red, we put the marble back in, and what's the probability that we are now then going to choose a red marble for event B? Well, we already know that these are independent events, so the conditional probability is just equal to whatever the simple probability is. Okay, so that's kind of nice. When these two things are equal to each other, then you know that they're going to be independent events. So then you say, well, what's the probability of getting a red one and then another red one? So 2 red ones in a row. And in this case, we multiply. It's fundamental counting principle. What's the first event that we have? Well, the first event is that you pull, for probability of event A, we pull red. Probability of event B, we pull red. 3/5 times 3/5 is equal to, multiply across, 9 out of 25. Starts to get a little bit more complicated when events depend on each other. So this classic thing that happens, it says do not replace it. So it's the same scenario, same setup. You reach into the bag, but you don't replace the marble back in for event A. So now we can't really talk about event B because the event B depends on what happens for event A. So the probability that A is red is still 3 out of 5. But now we have to think there's a condition here. Probability that B is red given that A is red and A is left out. So when we're looking at this, you're like, okay, well, the probability that B is red after we leave out a red marble, it decreases the red marble by 1. So we have 2 red marbles out of the new total marbles is going to be 4. So we have 2 red marbles out of 4 total marbles after we left a red marble out for the first selection. So therefore that affects what our intersection is. So the probability that A is red and that B is red in a row, so 2 reds in a row, is going to be the probability of A times the probability of B conditioned upon A. So the probability that B, given A was already red and left out, is going to be 3/5 times 1/2, which ends up being 3/10.